In the early years of the 20th century, Europe was knit together by two great innovations, the railway and the telegraph. Steel tracks stretched across nations, and wires pulsed with electric signals, shrinking distance and accelerating the rhythm of modern life. But these marvels created a subtle, practical challenge that would prove revolutionary: the problem of synchronizing clocks. For centuries, time had been local. Noon was when the sun reached its zenith, and every city set its clocks according to its own sky. This worked well enough when travel was slow, but as trains began to speed across borders, local time became chaos. If Munich declared noon 10 minutes later than Bern, a railway schedule could not be trusted. Telegraph operators struggled too. If a signal sent from Paris reached Berlin, what did it mean for the two clocks to agree on the exact second of transmission and reception? A few seconds error could mean a missed connection, a collision, or a tragic accident. Governments and engineers worked to solve the problem with conventions and systems. Standard time zones were introduced, railways demanded strict schedules, telegraph companies sought reliable protocols for clock coordination. Yet behind the technical fixes lay a deeper question. What does it truly mean for two events to be simultaneous? It was precisely here that Albert Einstein, sitting in the Swiss Patent Office, surrounded by patent applications for telegraphs and electrical devices, saw more than an engineering puzzle. Synchronizing clocks at a distance, he realized, was not simply a matter of sending signals and correcting delays. It forced one to confront the nature of time itself. If light or electrical signals took time to travel, then the act of coordination depended on how fast that signal moved and how the observer was moving in relation to it. Einstein began to imagine thought experiments. Two clocks in different cities connected by light signals. Could they ever truly be synchronized? If an observer were moving relative to those clocks, would he agree with their verdict of simultaneity? What if lightning struck two ends of a moving train? Would the passenger inside and the observer on the platform agree that the strikes occurred at the same moment? These questions led Einstein to a radical conclusion. Simultaneity is not absolute. What one observer calls now, another may call before or after, depending on their motion. The task of synchronizing clocks was not just a technical necessity for trains and telegraphs. It was a clue to the deep structure of the universe. In this sense, modern physics did not begin in a grand laboratory, but in the humble puzzle of railway timetables. The need for precision in human affairs, trains arriving safely, telegrams delivered on time, became the spark for a revolution that would redefine time and space for all of humanity.